Dreaming of a city on Mars? There's one massive, expensive problem: getting building materials there. Every kilogram launched into space costs thousands of dollars. Imagine sending all the bricks, steel and tools needed for even a small habitat. Costs skyrocket into billions of rupees. Rockets have limited capacity, and every launch is risky and complex. Relying on Earth for every nut and bolt makes a Martian colony fragile. A single failed launch could halt progress for years. For decades, scientists have searched for a smarter way. To put it in perspective, landing NASA's 1-ton Perseverance rover cost nearly 2,000 crore rupees. Sending enough material for a city? Unthinkable. The solution? Stop shipping everything from Earth and start using what's already on Mars. Mars's soil and atmosphere are full of untapped resources. The secret to building our future on Mars lies in what we can create right there. This idea could finally turn science fiction into reality. Enter a breakthrough from Australia. Scientists have figured out how to make iron using only Martian soil and gases. The Martian soil, or regolith, is rich in iron oxide, the same stuff that makes Mars red. The thin Martian atmosphere is mostly carbon dioxide. By heating simulated Martian soil in a carbon dioxide environment, they extract pure iron. This process, adapted from Earth's carbothermic reduction, works perfectly for Mars. At even higher temperatures, they can create silicon iron alloys, ideal for construction. With this tech, future astronauts could forge their own metals on Mars. No more waiting for steel beams from Earth. They could build habitats, tools, and vehicles themselves. This innovation could kickstart a self-sufficient Martian industry. It's the first real step toward a thriving independent settlement. This approach is called in-situ resource utilization, or ISRU, using what's found on site. Instead of packing everything, you use local resources, just like a camper brings a water filter instead of gallons of water. ISRU is the key to making long-term human presence on Mars possible and affordable. Every kilogram we don't launch saves money, fuel, and effort. ISRU lets us send smaller rockets or pack more critical supplies. It's not just about cost, it's about making Mars missions possible at all. NASA's MOXIE experiment has already made oxygen from Martian air, proving ISRU works. MOXIE splits carbon dioxide into oxygen and carbon monoxide, creating breathable air and rocket fuel. The Australian iron-making process complements MOXIE. One makes air, the other makes shelter. Together, these technologies lay the foundation for a self-reliant Martian colony. We're piecing together the tools to not just visit Mars, but live and work there. Turning lab experiments into full-scale Martian factories is a huge challenge. The Australian process made only small amounts of iron. We'll need tons for real habitats. Engineers must design automated reactors to process vast amounts of Martian soil in harsh conditions. Power is another hurdle. Iron extraction needs extreme heat and lots of energy. Solar panels are unreliable on Mars. Nuclear power may be the answer. We must ensure Martian-made iron can withstand freezing temperatures, radiation, and dust storms. Rigorous testing is needed to guarantee safety and durability. Automation is crucial. Factories must run with minimal human help. Robotic systems will mine, process, and build, freeing astronauts for science and exploration. Developing this robotic workforce is a massive task. These are tough problems, but exactly the kind that drive innovation. Mars is no longer just a destination. It's a place with resources for a new beginning. The dust once seen as a nuisance is now a planet-wide mine for building materials. This shift in thinking is key to a permanent human future beyond Earth. The journey is just starting, with obstacles to overcome, but the goal inspires us forward. Every breakthrough from making oxygen to forging iron brings us closer. The dream is about laying a foundation for a new branch of human civilization. Building with Martian soil is more than engineering. It's a new relationship with the cosmos. By using Mars's resources, we become true interplanetary citizens. The red planet's soil and air hold the keys to its own settlement. Building with Martian soil might be how we turn Mars into our next home.